Let us introduce tangent planes. Suppose you have a function. We're going back to elementary calculus. Let y be f of x. Suppose you have your function here, x-axis, y-axis, and here's your function. Y equals to f of x. To this function, at any point, you can define a tangent line. This is a tangent line. Remember that to write equation of the tangent line, the tangent line at y equals to f of x at x equals to a. Suppose this is x equals to a. We find the derivative of y equals to f of x and find the rate of change. Your y is equal to, well, mx plus b. That m is the partial derivative of f at a. And now we find the equation of tangent line to the function y equals to f of x. Now in multivariable calculus, instead of having a line, we're going to have a plane. So y equals to mx plus b, and m is f prime at a. Now, in multivariable calculus, two variable functions, z is f of x and y. It means that we have a surface. We can find the equation of tangent plane to the surface at a point A and B. So in this case, here we have, for example, x, y, and z, and you have your surface here. This is the surface of f of x and y. And you can define not just lines, planes that are tangent to your surfaces. This is a tangent plane. Now the question is, well, how do I write that equation? What's the equation like? The equation of tangent plane is written as z minus z sub 0 equals to, you're going to take the partial derivative of f with respect to x and calculate that at a and b. This is the rate of change of f with respect to x, which is a number, times x minus a plus, you're going to find the partial derivative of f with respect to y at a and b, another number, times y minus b. What is z sub 0? Z sub 0 is f evaluated at a and b. After simplifying, you're going to have the equation of tangent plane. This guy gives you equation of a plane that you learned in elementary calculus. Partial derivative with respect to x, partial derivative with respect to y, and then simplifying by distributing this number into parentheses and having equation of your tangent plane. Well, give us an example. What are you talking about? This is just an equation. Consider the elliptic paraboloid. I'm going to write down this example here. The elliptic paraboloid, which is defined as z equals to 2x squared plus y squared at the point 1 and 1, find the equation of tangent plane. Tangent. Okay. We have the formula. We need to follow the formula. This is my A. This is my B. Let me follow these. I need to find a partial derivative with respect to x, evaluate at a and b, find a partial derivative with respect to y, evaluate at a and b, and then I'm done. So partial derivative of f with respect to x is 4x. So partial derivative of f with respect to x at 1 and 1 is 4 times 1, which is 4. Now, the partial derivative of f with respect to y, this is just 0, so you get 2y. So the partial derivative of f with respect to y at 1 and 1 is just 2 times 1, which is 2. Very good. Now, what is z sub 0? Z sub 0 is 2 times 1 squared plus 1 squared, which is 3. I have all the information that I need. Z minus z sub 0, which is 3, is f of x 4 times x minus a, x minus 1, plus f of y, which is 2, times y minus b, y minus 1. Guys, you learned algebra. Don't leave it like this. You need to simplify. Z minus 3 becomes 4x minus 4 plus 2y minus 2. So z minus 3, or z, is 4x plus 2y minus 3. This is the equation of tangent plane to the elliptic paraboloid z equals to 2x squared plus y squared. We found the equation of the tangent plane as it is.